Let's try to factor the problems now. Our first step is to always try a GCF. So we need to take out a 3. It goes on the outside, and we have one big set of parentheses. Inside goes what would have to multiply by the 3 to get back to the original. So for the first term, we're missing an x squared. For the second term, just divide 3 into 75. You're missing a minus 25. Now, we have to look at the parentheses and see if it will do more. The GCF just comes down into your answer. And this parentheses, it is to the second power. So we'll go through our list. There are 2 terms. For 2 terms, you can try squares or cubes. Look at your exponent. The exponent is a 2. That tells us to try squares. And this one is a difference of squares. It's something squared minus something squared. To factor it, you go with the square roots. One set of parentheses with plus and one with minus. Now notice the exponents in the parentheses are down to 1. So we are finished. This whole thing is our answer. For problem 2, first of all, there is no GCF. Step 2, how many terms? There are 3 terms in this problem. It is one of the easy trinomials because the coefficient is a 1 of the leading term. So we'll go ahead to our 2 sets of parentheses. Also, you can do your sign rules. The sign of the last term is negative, so you're going to have 1 of each. You're going to split the x's, and you're multiplying to get a 28. So make your list. 1 times 28, 2 times 14, 3 doesn't work, 4 times 7, and I think that's all. Then it would flip over. And we want to combine those, subtract with different signs to get a negative 3. So 7 and 4, we want to get a negative 3. So we need to make sure that we put the negative with the 7. So negative 7, positive 4 should work there. Remember to check these on the outside and on the inside. Outside, minus 7x. Inside, plus 4x equals a negative 3x, and that works. Problem 3. First of all, we check, and there is no GCF. Step 2, look and see how many terms. This problem has 4 terms, so we're going to break it into groups. We're going to make 2 groups. A group here and a group here. In the first group, now we look for a GCF. So we could take out a 3, that's common, and leaves our parentheses to get back there. If we have the 3, we're missing a y. For the second term, you have a 3, you want to get a negative 21, so you're missing a negative 7. Then we'll leave that piece and go to the other group. There's a common factor of x in that group, so we'll take it out. To get back there, for the first term, you have the x, you're missing y. And for the second term, minus 7. What you hope you ended up with is a common binomial, which is a GCF for the entire problem, and we did. So now we can take it out. So y minus 7 is our GCF. We can take it out. And to get back just to the line above, this term we have outside, we're missing the 3. And for the second term, we have the y minus 7. We're missing the plus x. Problem 4. This problem is a special case of GCF. And in general, when you see one, it says factor, do not multiply. So we're going to take out our common factor, the common binomial. It can come out. And to get back to the line above, we have the x minus y, so we're missing the 7. And for the second one, we have the x minus y. We're missing the plus y. This particular kind I would not bother to check. The check takes too much work. You would have to do a FOIL, and you would also have to multiply the original. Problem 5. First step, check if there's a GCF. There is no GCF. This problem has two terms. Your choice for two terms is squares or cubes. The exponents of 3 tells us to try cubes. Your first job is to get the cube root. So we get the cube root of each term. For 27, the cube root is a 3. For a cubed, a, and b cubed, a b. For 8, the cube root is 2. And you factor this kind with a pattern. Use the cube roots with the sign of the problem. So 3ab plus 2. Second set of parentheses for a cube is a trinomial. It's the only kind like that. For your signs, the first sign will be the opposite of this one. So if this was plus, this one will be minus. Last one is always plus. Now you want all the combinations of your roots. So the first root times itself, 3ab times 3ab is 9a squared b squared. Second term is the first one times the second one. So 3ab times 2 is 6ab. And the last term is the last one times itself. 2 times 2 is 4. And this is done. The trinomial that comes out of a cube will not factor more. So you don't have to worry with a higher exponent than 1. It will not factor more when it comes out of a cube. Problem 6. This problem has so much stuff in it that you really should have a GCF. Otherwise, you're going to be stuck on this one. So we look for that first with the numbers, the biggest thing that goes evenly into all the pieces. And it looks like we could use a 5. For the variables, check the a's. If there's a in everything, we can take an a. Go with the lowest exponent. So we can use an a squared. And then the b's. There's b in everything. Go with the lowest exponent. That's our GCF. So step 1, we're doing GCF. Then we make our big set of parentheses. And to get back there, we will have 3 terms in this parentheses. What's missing to go times the 5a squared b? So we go term by term. We have 5, we want 30. So we're missing a 6. We have a squared. We're good. That's all we want. With a b, we want back a b cubed, so we're missing a b squared. For the second term, you have a 5, you want a 55. Just divide. We're missing 11. We have a squared. That's all we want. So we're good with the a's. We have 1b. We want b squared, so we need 1b. The last term, we have a 5. We want a negative 35, so we need a minus 7. The a squared's good. The b is good. So we factored part of it by doing a GCF. Now, our GCF is going to come down to the answer, but we have to see if this parentheses will do more because it's still to the second power. So now we'll go through how many terms we have. We're going to bring GCF down. And this is a trinomial. In the trinomial, it is not one of the simple ones with a 1 at the front. It is not a perfect square trinomial because 6 is not a perfect square. So this kind would have to go to trial and error. We would do 2 sets of parentheses. We would do our sign. So look at your last sign. This says our signs are going to be different. And we have our choices. For 6, we can try 6 and 1 or 3 and 2. I'm going to try the 3 and 2 and split the b's. And on this end, we can try 1 and 7 or 7 and 1. So we'll just first go with 1 and 7. Remember, you have to check outside and inside. So minus 21b plus 2b. And this one's not going to work. I'm getting a minus 19b. So I have to try something else. I'm going to keep the 3 and 2 and go to the next choice. Keep my signs, only change one thing at a time. So our check, outside minus 3b, inside plus 14b. This one's going to work, gives us 11b, and it's the right sign, so we're good there. Don't forget to bring your GCF all the way down. So we need the 5a squared b with this. And this last line, the whole thing is our answer. For problem 7, the first thing we should check is there a GCF? There is not a GCF that goes in all the terms. So second thing, we look at how many terms. There are 3 terms. This is not one of the nice trinomials with a 1 at the front. Our next choice, remember, is to see if it is a perfect square trinomial. And so we look, the first term is a perfect square, and the last term is a perfect square. So it is a good candidate for that. We go ahead with regular parentheses, regular sign rule. So this says like signs, both minus. And then we just guess the square roots. So we'll guess 3x, and for 100 it would be 10. And then we need to check outside and inside. So on the outside, minus 30x, inside, minus 30x, it's minus 60x, and that works. It gives the correct middle, so we're good. Sometimes you will see this answer written, because it's the same, they might write it in a more compact form with just one set of parentheses and an exponent. I like the first one better because you can do your check from there, but both are correct. And our last problem. First, we would look for a GCF. There is no GCF, so we look at how many terms. There are 2 terms. For 2 terms, your candidates are squares or cubes. You need to look at the exponent. Your exponent is a 2, so you're going to try squares. Difference is squares have to have a perfect square minus a perfect square. And this one looks good. It will go into 2 sets of parentheses. You always have different signs and use the square roots. So a 5x and an 8y. And if you check your outside and your inside, the middle term will cancel, which is what you want.